All right, that brings us to the Pythagorean identities. So the idea behind the Pythagorean identities is, if you look at this picture that I have over here, we call this point on the unit circle xy. Okay. Now I kind of wish, here, let me see if I can do it right now. If I drop a perpendicular going down this way so that I make a right triangle, then the bottom of this triangle would have length x, the side of the triangle would have length y, and the hypotenuse of the triangle would have length 1, which means, okay, I'm feeling really frisky today, so I'm going to try this. So that means that, oh, well, I just thought of another simpler reason we know this. That means that x squared plus y squared equals 1. The simpler reason that x squared plus y squared equals 1 is because that point is on this unit circle with the equation x squared plus y squared equals 1. So then if you remember that the sine of t is y, the sine of t is y, and the cosine of t is x, then I can just replace y with sine t. I've kind of got the things, well, sort of placed a little funny. Y is sine t, and x is cosine t. So if I replace x with cosine t and I replace y with sine t, that gives me the sine of t squared plus the cosine of t squared is 1. And I just realized this is the first time that we're seeing this notation. They use this special notation that students often don't understand very well right at the beginning. You see how the second power is right next to sine. This notation, sine squared t is how I usually read it, means take the sine of t and then square it, all right? So sin is not a number. It's not that sin is being squared. It's that sine t is being squared. It's just that somebody came up with this notation probably to avoid having to use parentheses. It does not mean the same thing, and you're going to find that you don't write this very often. It does not mean the same thing as the sine of t squared. What that means is take the square of t and then take the sine of the answer. So this is not what we're talking about. And again, that's something that you don't see very much. Okay. Sine squared t plus cosine squared t equals 1 is a super, 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 super important identity. That's one that you're going to want to get yourself to the point where you know that, you know, inside, outside, in your sleep. Okay. I want to talk, though, about these other two identities, all right? I first learned this stuff a long, long time ago. I don't want to say how long. And I've been using it ever since. And to this day, even all those years later, I would say, first of all, this has a typo in it. I'm going to pause this while I fix the typo. All right, we fixed the typo. And I was saying that I would say that I do not feel still to this day 100% confident that I have either of these identities memorized. So I want to show you every time I need one of these identities, and I do need them fairly often, I want to show you how I get them. I actually derive them from sine squared t plus cosine squared t equals 1. So I want to show you how I do that. So here is how I get the second one there. Okay. I start with sine squared t plus cosine squared t equals 1, and then I divide everybody by cosine squared t. Okay, that I can remember to do. And then if you think back to your quotient and reciprocal identities that I think we just got through talking about, sine t divided by cosine t is tangent t, which means sine squared t divided by cosine squared t is tangent squared t. Of course, anything divided by itself is 1. Anything divided by itself is 1. And the reciprocal of cosine t is secant t, which means the reciprocal of cosine squared t is secant squared t. Okay? Each and every time I need the identity that relates tangent t to secant t, and all I remember is that there is an identity like that. See, my problem is that I'm afraid I'm going to put the +1 on the wrong side. And so each and every time I need that identity, I sit down and do this. I've probably done it 200 times over the last however many years. And then if I need this identity, I do the same thing, except I divide everybody by sine squared t. See how I do that? I take sine squared t plus cosine squared t equals 1. I divide everybody by sine squared t. Anything divided by itself is 1. Cosine t divided by sine t is cotangent t. And the reciprocal of sine t is cosecant t. So those are your Pythagorean identities. And coming up next, we're going to do an example where we use some of those. Okay, so here's an example of using a Pythagorean identity. They're telling me that the sine of t is 1/2. And for some reason, they're telling me that t is between 0 and pi over 2. And that is supposedly enough information to find the value of cosine t. Okay. All right, so here's how that works. I start with my identity that relates sine t to cosine t. That's the one we were just talking about. Sine squared t plus cosine squared t equals 1. And since they told me that the sine of t is 1/2, I can replace sine t with 1/2. See how that works? And again, it really helps if you understand the special notation here. This means the square of sine t. And so if I replace sine t with 1/2, it becomes the square of 1/2. Okay. So now I have 1/2 squared plus cosine squared t equals 1. Of course, the square of 1/2 is 1/4, right? So 1/4 plus cosine squared t equals 1. I am going to subtract 1/4 from both sides. So this 1/4 is going to disappear, and then 1 minus 1/4 is 3/4. Okay. So if I was doing this on the whiteboard, let me show you how I would have shown my work there. I would have gone under here and I would have written minus 1/4 minus 1/4. Okay. So this 1/4 minus 1/4 cancels, and that's how you get the 1 minus 1/4 over here. 1 minus 1/4 is 3/4. So now I'm going to use what we call the square root property. If the square of a mystery number is 3/4, then that means that the mystery number must be, okay, I have a complaint about the way they wrote this, so I'm going to fix this. Try to remember to fix it for good later. So normally, if you know that the square of a mystery number is 3/4, then all that tells you is that the mystery number is either, I was feeling good about the pen, and then, okay, is either the positive or negative square root of 3/4. So technically at this point, all I know is that cosine t is either the positive or negative square root of 3/2, okay? But the reason I know that it's the positive one is because they told me that t is between 0 and pi over 2. And when t is between 0 and pi over 2, I'm going to try something different here. T between 0 and pi over 2 is in the first quadrant, isn't it? So here is 0. Here is pi over 2. So that means t is in here somewhere. Okay. And remember, x and y are the coordinates of this point. So I can see from that picture that both x and y are positive, all right? So it is not negative, let me see, what would be a good way to cross this out? We'll cross it out like this maybe. All right, so it's just square root of 3 over 2. Whoops, gotta change my pen. Square root 3 over 2, not plus or minus, just plus. All right, next we have periodic functions. It turns out that all of our trigonometric functions are periodic. Periodic basically means repeating. So what this says is a function f is periodic if there exists a positive number p such that f at t plus p is exactly the same thing as f of t. Now it's hard to understand what that means maybe until you see an example, all right? And so you're going to see in just a minute how this relates to our trig functions. This is kind of just a vocabulary thing. The smallest positive number p for which f is periodic is called the period of f. Okay? So here's sort of an everyday example of periodic. It's not perfect, but I think it'll kind of get the point across. The function that gives you the temperature, or let's say the average daily temperature as a function of, what day is it, is sort of periodic. All right, today it happens to be August 21st as we're doing this. And I don't know what the average temperature for August 21st is. Let's say it's 90 degrees, all right? If I add 12 months to August 21st, then what I'm going to get is August 21st of next year, and that'll have the same average daily temperature, okay? So the average daily temperature has a period of 12 months. It repeats every 12 months. That's sort of an everyday example of periodicity, I think is the word for that. What a great word. All right. So it turns out that sine and cosine are both periodic functions, and I'm going to explain why. And their periods, both of them, are 2 pi. And here's the reason that the period of sine and cosine are both 2 pi. Okay. So let's say I go to the value t. In this picture, the sine of t is y and the cosine of t is x. If I add another 2 pi to the value of t, what that's going to do is just go all the way around the circle and land at the same point. All right. And so the sine of t plus 2 pi, and here's what t plus 2 pi looks like. Here, let me do it like this. T plus 2 pi starts here, goes all the way around, and then lands at this same angle, all right? And so the point on the unit circle is still the same x comma y. So the sine of t plus 2 pi will still be y, and the cosine of t plus 2 pi will still be x. Tangent and cotangent are also periodic functions. The period of those functions is pi. And let me try to explain to you why that is. So if I pick up my pen here. So at the point, well, at the angle t, think of this as an angle. This point is xy. So we've talked previously about how the tangent of t then would be y divided by x. Y divided by x. That's the definition of tangent. Whoops. Okay. All right. Okay, so now let's say I go over to t plus pi. T plus pi would be this angle here, wouldn't it? Okay, exactly 180 degrees past t. So the coordinates of this point would not be x comma y. Oops. The coordinates of that point would be negative x comma negative y, wouldn't they? Negative x, negative y. Okay. So technically, if I want to talk about the tangent of t plus pi, which is this angle here, t plus pi. Sorry about that. That would be negative y divided by negative x. But of course, negative y divided by negative x is the same thing as y divided by x. Okay, so it gives you the same. It gives you the same value for the tangent. Okay, the same exact kind of thing works for cotangent. The only difference is that cotangent is x divided by y. Okay, so the tangent and the cotangent both have period pi. Okay. This looks similar to the last couple slides. So for example, 2 slides ago, it said that the sine of t plus 2 pi is equal to the sine of t, and the cosine of t plus 2 pi is equal to the cosine of t, et cetera, et cetera. What this number n is, it's just saying that you could go around and around as many times as you want. And as long as you go by a multiple of 2 pi for sine or cosine, or you go by a multiple of pi for tangent, then you will still keep landing in that same point. All right, let me try something here. So I would have just put my usual picture here if I had thought about it. That is a weird looking circle. Okay, and let's say this is t, all right? And this is the point x comma y, all right? What this is saying is that if you take the sine of t, that's going to be y. If you go around once and get the sine of t plus 2 pi, it's still going to be y. If you go around a second time, then that would be the sine of t plus 4 pi. That would still be y. Or even if you went around in the other direction, so let me start over here. Let's say I went t minus 2 pi. T minus 2 pi would look like this, going clockwise. And that would still be y, all right? That's what that's saying. It's just saying you don't have to go around just once counterclockwise. You could go around as many times as you want, either clockwise or counterclockwise. Okay. All right, so let's try the example. If I can get there. Here we go. Okay, so they want me to find the value of the cotangent of 5 pi over 4. Now 5 pi over 4 is not an angle that, that we've talked about before. So here's what I'm going to do to find this value. I'm going to say, okay, I know that the cotangent function is periodic. It has period pi. So instead of talking about 5 pi over 4, why don't we talk about 5 pi over 4 minus pi, all right? So the periodic property is saying that if you add or subtract a multiple of pi to 5 pi over 4, it'll still give you the same value. So it's saying that the cotangent of 5 pi over 4 is exactly the same as the cotangent of 5 pi over 4 minus pi. And it just so happens that 5 pi over 4 minus pi, let me scribble something in here, is pi over 4. Why is that? Because if you get a common denominator, the common denominator would be 4. So think of this as 4 pi over 4. 5 pi over 4 minus 4 pi over 4 is just pi over 4. And in a previous example, we did figure out that the cotangent of pi over 4 was 1. Okay. All right, let me see. Okay, so this might be a good one for you to try if you're watching at home. Pause the video and try this one. I will tell you one thing that's different about this one. Feel free to use one of your even or odd identities. Might make this a little easier. Okay. So I'm going to pause recording. I'm going to give you folks at home a chance to figure this out, and then we'll compare notes. Okay, so hopefully you had a chance to try cosine of negative 9 pi over 4. So the first thing I want to remind you of is that cosine is an even function, which means you can take this negative sign and basically ignore it. So that's the first thing I'm doing, going from this step to this step. I'm dropping the negative sign because cosine is an even function. All right, now remember that the cosine has a period of 2 pi, which means I can add or subtract multiples of 2 pi to get to an angle that I'm already familiar with. So it just so happens that if I subtract 2 pi and I get a common denominator, which would again be 4. Let's see, maybe it would help if I added one step right here. Okay, so I'm going to write cosine of 9 pi over 4 minus 8 pi over 4. That's just getting a common denominator. All right, and then of course the 9 pi over 4 minus 8 pi over 4 is pi over 4. And we already determined in an earlier example that the cosine of pi over 4 is square root of 2 over 2. So finally, the last topic in 4.2 is how to use your calculator to evaluate trigonometric functions. So you'll see when you look at your calculator that you have buttons marked sine, cosine, and tangent. Now it's very important to put your calculator in the right mode, meaning either degrees or radians. I always enjoy telling this story. I had a student several years ago. I had a student many years ago who was taking calculus and physics at the same time, and this student was so worried about leaving his calculator in the wrong mode, and I guess he had a little bit of money burning a hole in his pocket. He bought a second calculator and used one only for calculus. He left that one in radian mode, and he bought one for physics that he only used for physics that he left in degree mode. All right. So I'm not saying that you have to be that extreme about it. You just have to make sure that you're in degree mode when you're using degrees and you're in radian mode when you're using radians. Okay. All right. So here are the two examples that I'm going to show you, and I'm showing them to you at the same time because I think that what I have to do when I switch over to my calculator is I have to change a little something on my program that I'm using to record. So let's just make a note of, we're going to use a calculator to find the sine of pi over 4 and then the cosecant of 1.5. Okay, so here I am with my TI-84 Plus graphing calculator. It's probably pretty similar on a scientific calculator. So remember, first of all, I'm going to check to see what mode I'm in. So on this calculator, the way that works is you press mode, and I see that I am in radian mode. I see that right there. Okay, so I'm going to quit out of that. And now the first example was the sine of pi over 4. We actually know the exact value of sine pi over 4. So we can use that to check our answer. I'm going to click sine. And then to get the pi symbol, I have to go second and then the exponent button on this calculator. On yours, it might be different. And then over 4. You don't actually have to close the parenthesis. The calculator is smart that way, but I'll do it. And I hit enter, and it tells me that the approximate value of sine pi over 4 to 4 decimal places, that's what they had asked for, is 0.7071. So I'm going to box just the 0.7071. Okay. Since we know that the exact value of sine pi over 4 is square root of 2 over 2, let me ask my calculator, what is the square root of 2 over 2? They should come out to be the same. So I'm going to go second x squared. That's how you get the square root button. And I'm going to put a 2 there. Now I have to back out of this square root. Okay. Your calculator might give you a square root and then a parenthesis. If it does that, you just want to close off the parenthesis after this 2. All right. You're telling it what to take the square root of. Okay. So my calculator is telling me that the square root of 2 over 2 is the same exact value. Okay. So that agrees with what we already know. Okay. Remember that the next example was the cosecant of 1.5. Now, cosecant is a little bit different. Your calculator probably does not have a cosecant button. So you need to use your reciprocal identity. You have to use the fact that the cosecant is the reciprocal of the sine. So instead of putting cosecant 1.5, we're going to put 1 divided by sine 1.5. All right. And I am still in radian mode because it said cosecant 1.5. It did not say cosecant 1.5 degrees. Whenever you don't see a degree symbol, it's fair to assume it means radians. Okay. So 1 divided by the sine of 1.5 to 4 decimal places would be 1.0025.